Hey everyone, and welcome to This Explainer. Today, we're doing something really cool. We are lifting the hood on a modern machine learning web application. We're going to demystify exactly how state-of-the-art AI models are actually deployed out into the real world for people to use. Specifically, we're unpacking a project that deploys the incredibly powerful YOLOv8 real-time object detection model. We'll be looking directly at the source code structure and the architecture that makes the whole thing run so smoothly. So if you've ever wondered how heavy machine learning models are cleanly served straight to a web browser, well, you are definitely in the right place. Okay, let's dive right into this. Here is our roadmap for today. We're going to start with the object detection stack, move into Streamlit for our web interface, and then uncover the FastAPI app backend. From there, we'll take a deep dive into the detect endpoint and finally wrap up with spinning up the services. It's essentially the complete journey of a request from the front end down to the core engine and back out again. All right, kicking things off with Section 1, the Object Detection Stack. To really wrap our heads around this architecture, I want you to think of it kind of like a well-oiled restaurant. The front end is the dining room where the customers sit, and the back end? That's the kitchen where all the heavy lifting and the actual cooking happens. It's a brilliant separation of concerns. In our source project, the root directory is split into two main hubs. On one side, we have the API directory. This is our kitchen, powered by FastAPI, and it handles all the heavy machine learning computation. On the other side, we have the UI directory. This is our Streamlit application, our accessible dining room. By splitting these up, the app ensures your web browser never gets completely bogged down trying to do the intense math required to find objects in an image.
And what's the ultimate goal of all this architectural planning? Well, it's to create a fully containerized, real-time object detection service using the state-of-the-art YOLOv8 model. Now, YOLO stands for You Only Look Once, and this 8th version is famous for being incredibly fast and highly accurate. By wrapping it in this specific stack, developers take a highly complex model and make it incredibly accessible, reliable, and honestly, just super easy to deploy anywhere.
Moving right along to Section 2, Streamlit, the web interface. Let's step right into the dining room of our app, because this is where the user experience actually begins. This interface is built with Streamlit, which is just a fantastic Python library for building data apps fast. Notice that the UI runs over on port 8501. This is where the user basically places their order. They upload an image, your standard JPG, JPEG, or PNG formats. And they also get some controls, like a slider to adjust the confidence threshold. This is basically the user telling the system, hey, only show me objects you are at least this certain about. And finally, this is where those detected objects, complete with their visual bounding boxes, are displayed right back to the user. Pushing through the swinging doors, we arrive at Section 3, FastAPI, the app backend. Welcome to the kitchen. This is absolutely the brain of the whole operation. The backend is powered by FastAPI, and it runs completely independently on port 8000. If you haven't used it, FastAPI is a really modern, blazing fast web framework for building APIs in Python. It houses our main application logic and does the critical job of serving those YOLOv8 predictions. It does this by opening up specific endpoints for the front end to talk to, specifically a health endpoint just to check if the server is awake, and the all-important detect endpoint. And notice how beautifully lightweight this is? It literally just waits for an image, runs the prediction, and serves the raw data back, completely detached from how that data is going to be drawn on the screen later. Which brings us nicely to Section 4, a deep dive into the detect endpoint. Let's zoom right in on the exact bridge that connects our front and back ends. This right here is the true technical core of the system. The post-detect endpoint is the primary API mechanism for the entire architecture. Sticking with our restaurant analogy, this endpoint is essentially the waiter passing the order between the dining room and the kitchen. The Streamlit UI sends an HTTP post request to this exact URL, handing off the user's image so the YOLOv8 model can get to work. Now, to actually make a successful request, this endpoint needs a couple of specific things. First and foremost, obviously, it needs the image itself, which gets sent over as a multi-part form data file. Second, it accepts a confidence threshold. What's cool here is that this is actually an optional float value. If the Streamlit front end doesn't happen to provide one, the FastAPI backend just automatically defaults to 0.25, meaning it's going to return objects that the model is at least 25% confident it has correctly identified. Now, what's really interesting about this slide is the exact structure of what the kitchen sends back. This is a look at the real JSON payload generated by the FastAPI backend. See how it returns an array called detections? Inside of that, we get a box with 4 precise coordinates, a label that identifies a person, and a confidence score of 0.92, so 92%. It also really smartly includes a summary object down at the bottom, just totaling up everything it found, in this case, one person.
This is the pure, unfiltered data that the front end receives. So let's map those raw JSON keys directly to their real-world functions over in the Streamlit UI. The box coordinates, those are what Streamlit uses to literally draw those recognizable squares around objects on your screen. The label is the text it writes right above that box, telling you if it's a person, a car, or maybe a dog. The score is used to ensure the UI actually respects your slider settings. And that summary? That allows the UI to instantly display a clean little dashboard metric, like, hey, 3 cars and 1 person detected, without having to manually loop through and count the individual boxes. It's just a beautifully synergistic relationship.
But wait, there is one more really clever architectural trick happening here. Alongside passing that JSON data, the API also saves a fully annotated version of the image to a local output directory. Because both the backend and the front end are containerized, this architecture uses Docker volumes to safely share this output folder between them. It's a massively efficient way to pass the finished visual asset back to the user without having to lug massive image files back and forth inside the API response itself. Pretty smart, right?
And finally, Section 5, spinning up the services.
We've seen the code, we've traced the data flow, so let's move to how this actually builds out in the real world. Because of the containerized architecture, it is a remarkably simple 3-step process. First, you just clone the repository. Second, you configure your environment variables by copying a provided template. This is where you can tweak things like your custom ports. And third, you just run docker compose up -build -d. That one single command reads the config and starts orchestrating the whole shebang we've been talking about.
There is actually some real deployment magic happening behind the scenes during that third step. To keep the code repository nice and lightweight, those heavy YOLOv8 model files aren't actually stored in version control. Instead, during the build process, a dedicated shell script dynamically reaches out and downloads the required model right into the API container. The containers install their dependencies, and boom, they boot up. You can then just run docker compose ps to verify that the API service is successfully reporting is healthy. Taking a quick look at the project's language composition, this brilliantly illustrates how Python-heavy and script-light this deployment really is. Over 76% of the codebase is Python, powering all that fast API and Streamlit logic. About 15% is dedicated to the Docker files containerizing those apps, and less than 9% is shell scripting, which is just used for things like dynamically grabbing our model. It's an incredibly focused modern tech stack. And that brings us to the end of our explainer. We've seen exactly how effectively you can serve a really complex model like YOLOv8 just by strictly separating your front-end interface from your back-end computing power. So here's a thought to leave you with today. By utilizing this exact decoupled container blueprint, how could you swap out YOLOv8 and adopt this fast API and Streamlit architecture to easily deploy your very own custom machine learning models to the world? It's a really powerful template, literally just waiting for your ideas. Thanks so much for joining me on this deep dive.